Welcome to the Executive Protection and Secure Transportation Podcast. I'm your host, Larry Snow. The podcast is provided by the International Security Driver Association, where every week we share secure transportation and executive protection headlines, news, trends, and educational content for today's practitioners. Hello, and thank you for joining me for episode 192 of the EPST podcast. In this week's episode, the topic is best practices for protective driver training. This is the first in a series of podcasts that we will cover best practices for protective driver training. We have close to 50 years of experience conducting various driver training programs and services that had to withstand the scrutiny of corporate security community, corporate legal, human resources, and compliance departments, along with government and military organizations, which are not bashful to tell you exactly what they think. A portion of the podcast is taken from the foreword of Joe Otera's book, The Professional Guide to Planning, Managing, and Providing Secure Transportation. First and foremost, driving and driver training is a science. When looking at driver training and the skills necessary to drive at the highest level, there has to be a great deal of research done, money spent, and data collected that allows us to understand better how drivers make decisions in emergencies and how long it takes them to make the decisions that determine success or failure. The end result of all this research is the advancements that have been made in measuring driving skills and therefore survivability in an emergency scenario. For most, any attempt to practice evasive driving techniques outside of a controlled training environment, especially while they're behind the wheel of a principal's vehicle, is certainly a career-ending opportunity. This places an added emphasis on the need for evasive driving training that provides results that are repeatable and sustainable. In turn, this makes selecting the right training provider and the right training course one of the most critical decisions a driver or practitioner must make. Some of the factors that determine the quality and value of the training include what, if any, is the performance standard that drivers are required to meet, the vehicles and the environment that the training will be conducted in, the number of exercises the driver is required to complete, parameters of each exercise and the conditions under which they must be performed under. For those professionals responsible for ensuring the principal's safety and security while being driven from one location to the next, the further the training strays from the real-world conditions, the more artificialities that exist, the less useful the training becomes. The driver needs to be able to react to behind-the-wheel emergencies. Determining whether a driver has the capability to manage the limited time, distance, and maneuvering that defines a behind-the-wheel emergency requires measuring more than just one aspect of their performance as they drive around some cones. It requires measuring a driver's performance in a series of increasingly complex exercises which closely replicate the parameters of behind-the-wheel emergencies, account for human performance factors such as reaction time, fatigue, and stress, account for advances in automotive technology and the impact they have on vehicle performance, are conducted in a wide range of realistic conditions, such as transitioning from improved to unimproved surfaces in daylight and in low-light conditions. In that regard, while training to an objective standard is important for the professional security driver, their training must also provide them with the capability to consistently utilize a high level of their vehicle's performance potential in terms of cornering and braking, within conditions that are as similar as possible to those the driver is likely to face outside the training environment, in exercises that present the driver with limited time, limited distance, and limited maneuvering space. In other words, the focus of the advanced driver training should never be just achieving the performance standard. The focus should be on providing drivers with the skill and ability to overcome the challenges that they may encounter beyond the training environment. No matter how long it has been since the driver participated in the training, when properly applied, a science-based, objective performance standard is just the tool by which those attributes are measured. The idea that providing training without objectively measuring performance is nothing more than entertainment holds for all sorts of training, including driver training. But just because there is a training standard thrown somewhere into the mix doesn't necessarily mean that a particular course provides any more value than one which has no standard. Training drivers to some arbitrarily standard in vehicles, environments, and conditions that do not closely replicate those which the driver will have to contend once they leave the course is no different than asking them to drive at night in the rain with the windshield wipers on but their headlights off. Being able to train drivers as they drive requires more than just up-to-date vehicles. It also takes the ability to replicate as closely as possible the factors that influence the driver's ability to recognize and respond appropriately to a behind-the-wheel emergency. On the other hand, no matter what environment the training takes place in, failing to accurately replicate certain factors and reduce artificialities to the greatest extent possible can place students at a distinct disadvantage if or when they find themselves in an emergency situation. Factors that must be considered. Reaction time. When it comes to driver training, one of the most common and most detrimental artificialities are the amount of time that a student is provided to recognize the onset of the problem, develop a solution for it, and begin implementing that solution. Research shows that the time available to perform those critical mental and physical tasks during real-world events is exceedingly short. Any driving exercise that does not precisely control the reaction time provided to the driver or practitioner is likely to be of limited value in real-world conditions. Decision sight distance. This factor is related in some respects to reaction time and represents the single greatest artificiality that evasive driving exercises must overcome. Decision sight distance is the distance needed for a driver to detect unanticipated changes, recognize the risk created by those changes, identify the appropriate path and speed needed to initiate and complete the evasive maneuver. With that definition in mind, there are 3 reasons why it is crucial to accurately replicate decision sight distance in the training environment. First, assuming the instructor is doing their job properly, the student will have a clear understanding of the problem they will be faced with once they are briefed on the exercise and its objectives. Secondly, they will know exactly how they are expected to solve the problem via the same exercise briefing. And thirdly, they will see where the problem is in relation to their vehicle well before they enter it. None of those conditions or circumstances will exist when they are driving the principal from one place to another. So, the decision sight distance available to the driver in the training environment must be minimized by some other means in order for the driver to receive the maximum benefit from each training exercise. This is accomplished by dictating where and when the driver can begin solving the problem in relation to the obstacle or obstacles in the vehicle's path. Indicators and warning signs. In evasive driving exercises, presenting the driver with an indicator or warning sign that they are approaching a potential problem is the most effective way to accurately replicate the limited reaction time and decision sight distance that they will have to work with within the real-world event. While this can be accomplished in any number of ways, for example with voice command or using manually activated remote-controlled lights operated by an instructor, neither of those approaches is precise or accurate enough to measure and assess the driver's performance accurately. Variations of just 2 or 3/10 of a second, the blink of an eye, in when and where the driver is given the signal can significantly alter the outcome of the exercise by making it either easier or harder for the driver to perform to a standard. There are alternatives to those outdated approaches, but those options are expensive and require some advanced technical knowledge and an in-depth understanding of human performance factors on the part of the instructors. However, the benefits the students receive from training that properly integrates these highly advanced training tools into the learning process are almost immeasurable. Maneuvering space. The dimensions of every evasive driving exercise are critical in terms of creating rates of deceleration, the rate of weight transfer, and the ADAS engagements that the driver will have to manage in a safety or security-related emergency. The width and depth of an obstacle, the width of the lanes that parallel those obstacles, as well as the distance between the entrance of the exercise to the first obstacle and the distance between every obstacle after that one, directly influences when and how the driver manipulates the vehicle's controls and how the vehicle responds to those inputs. Properly designed evasive driving exercises do not just create load on a vehicle. Simply driving around a big circle while increasing speed every lap is all that is needed to do that. But most drivers would be hard-pressed to recall encountering a behind-the-wheel emergency where driving around a circle at a high rate of speed was the way to solve the problem. Exercises that provide the most training value are those which replicate a known incident or situation as closely as possible, create the same forces that a driver will experience in a behind-the-wheel emergency, will result in ADAS engagements where and when they are likely to occur in an emergency, and allow for the accurate measurement of driver performance. Here are some concepts that need to be explained and discussed. Feet or kilometer per second. Driving is managing time and distance. When measuring time and distance, the term miles per hour or kilometers per hour is irrelevant. The instructor must use the concept of feet or meters per second. Lateral acceleration is the vehicle's output created by a combination of speed and steering. It is impossible to conduct driver training without knowing the vehicle's output due to the driver's input in the exercise design. How can the instructor know what the driver capability is if they don't know the vehicle's capability? The concept of G's. The product of lateral acceleration is G's. G's are the result of the vehicle characteristics combined with the driver's inputs. G's represent the driver and vehicle level of performance. G's are a standard unit of measurement used to determine driver and vehicle capability. Braking. All braking exercises and scenarios must be measured. The output of applying the brakes is a measurable quantity. It is a combination of speed, time, distance, with the result being a unit of measurement called G's. Comfort zone. The comfort zone combines speed, steering, and/or braking where the vehicle reacts as the driver expects. As the driver increases the speed, steering, and/or braking creates and goes past his comfort zone. There will be a big change in the way the vehicle responds, changes that are not expected, which will create anxiety. Going beyond the comfort zone is not done on purpose. It is a place visited only when bad things are happening. One of the goals of a driver training program is to raise the amount of steering, braking, and speed a driver is comfortable with. Linear driving. Small changes in speed create big changes in the vehicle's output. There's a combination of speed, steering, and/or braking that creates big changes in the way the vehicle responds, changes that are not expected and that make anxiety. Vehicles are not linear machines as a vehicle approaches the limits of its design. Prior to driving into a scenario, the professional driving instructor must have the ability to compute the speed at which the vehicle will approach its design limitations. Understeer and oversteer is the vehicle's response or output produced by the driver input. You supply the vehicle's input, i.e. steering, gas, and braking, from the input supplied. The car produces an output. The output is the vehicle talking to you. It usually happens when your car is approaching its limits. When the input combines speed and steering, the phenomenon is called neutral steer or over and understeer. Under and oversteer are terms used to explain vehicle characteristics, and they are essential signals transmitted to you by the vehicle. It is how the vehicle communicates to you. It is the vehicle's way of telling you what you should do next. In a nutshell, understeer and oversteer are the interrelationships of the front and rear ends of the car, tire pressure, and the contact patch. All vehicles are supplied by a cushion of air contained in 4 flexible rubber tires. If you could place a car on a glass floor and look at it from below, you would see 4 patches of rubber. Most folks are surprised at the size of these 4 patches. Depending on the vehicle, each patch is a little smaller than a hand. These are the only points of contact between the vehicle and the road. Each of these 4 small patches of rubber is known as the contact patch. It is these 4 patches that create the traction that makes the vehicle go, stop, and turn. These 4 patches send the feedback to the driver, and it is these 4 patches the driver has to manage. Consider them to be a source of information needed to control the vehicle. In a future podcast, we'll be covering training, vehicle, and driving exercises. That will do it for me this week. Thanks so much for tuning into the podcast. If you haven't done so already, be sure to subscribe to the podcast from your favorite podcast app so you won't miss future episodes. The accompanying blog post for this episode has links to all the topics I shared. That link is securitydriver.com/podcast. Then click on episode 192. We welcome any comments, feedback on the podcast, or from topics that were discussed. If you have a moment, we'd really appreciate a review of the podcast. A review helps us make the podcast better and reach more people. If you have an interest in going much deeper into these types of topics, I invite you to check out the International Security Driver Association's website and consider joining the membership to gain access to the Encyclopedia of Executive Protection and Secure Transportation, the ISDA Knowledge Center. For more information on all the member benefits, head on over to isdacenter.org.